This is one of my favorite proofs, just for fun. I mean, we can put proof under scare quotes, but we're going to try to prove that adding all the natural numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6, infinitely adding, would equal to the number -1/12. Okay, this proof comes up in a lot of, or there's different versions, or I should say there's different proofs of this, but it's fun. All you need is elementary algebra to understand the proof. Okay, so I'm going to try to prove this. All right, and we're going to say this is kind of proof, right? Okay. Well, I need to build up a few tools to do it at first, so seemingly out of nowhere, I'm going to bring up this other series that seems that it's completely unrelated, but I need to build my tools up. So I'm going to bring up series 1, which is just alternating, adding 1, subtracting 1, okay, infinitely. All right. Now, if you take Calculus 1, or maybe it's Calculus 2, you'll formally prove that, of course, this does not converge, okay, to a finite sum. And if it does convert to a finite sum, then that would have to be 0. But I'm going to show in this weird way that this equals something else. So what do we have here? Okay, well, we have 1 minus 1 plus 1 minus 1 forever, okay? We're just never going to stop. If I do stop at any point, it just goes to 0, okay? So we have to watch out for that. But what happens if I do it in this strange way? I'm going to do 1 minus this series. Okay, so 1 minus this series. Forever. Okay. Now this is just where basic algebra comes in. I'm going to distribute that negative sign. Forever. Okay, so what did I just show? I just showed that 1 minus the series equals that series itself. Oh, that's strange. Okay, so if I move this to the other side, whoops. So 1 equals 2 times that series, so that series must equal 1/2. Okay, so I'm saying that this equals 1/2. How does that make any sense? Well, the idea is that because this is going between 1 and 0, that if you think about it going infinitely fast, that this would average out to 1/2 in a certain kind of way. All right, so that's the first idea. Okay, now the second idea might seem completely unrelated, and maybe it is, but let's see. So I'm going to come up with this other series, and it's going to be 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. Now this is almost the series I'm trying to calculate, but has this alternating minus sign. I'm going to try to find out what this equals in this weird way. What I'm going to do is I'm going to take series 1 minus series 2, and I'm going to see what happens. Alright, so what I'm doing here is 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. And what I'm going to do is I'm going to subtract it. Okay, so if I do that, 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. Okay, so what does that equal? Okay, well, in this way, I can just factor out terms. This is where just basic algebra comes into play. But 1 minus 1, -1 plus 2, 1 minus 3, -1 plus 4. Okay, that might be enough to see what's going on here. So what do we have? 0 plus 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. And what is this? That's series 2. So what did I show? Series 1 minus series 2 is series 2. Series 1 equals 2 series 2. Okay, well, series 1, if you believe me before, was 1/2. So 1/2 equals 2 series 2. So series 2 must equal 1/4. Okay, I need this result to do the end. Okay, I only have one more step to go. Okay, so from that result, I'm going to solve for our natural counting numbers. Okay, so I'm going to call them series n, the natural numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 forever. Okay, what I'm going to do is I'm going to take series 2 minus series n and see what happens. Okay, so what is that? 1 minus 2 plus 3 minus 4 plus 5 minus 6, so on, minus 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, what does this equal? Well, that's 1 minus 1, that's just 0, plus negative 2 minus 2, plus 3 minus 3, plus negative 4 minus 4, plus 5 minus 5, and so on. I ran out of room, so and so on. And what is this? That's just 0. That's negative 4. That's 0. Negative 8. 0. So that's what's happening. 0 minus 4 plus 0 minus 8 plus 0 minus 12 plus 0 minus 16, and so on. Alright, what does that mean? Negative 4 minus 8 minus 12 minus 16 minus 20, and so on. That's all that's going on. Okay, so it doesn't look like much is happening that we've seen before, but here comes another algebra trick. So you can factor out the negative 4. If you do that, what do you see? Then you just have the counting numbers. Okay, so what does that mean? That means that series 2 minus series n is negative 4 times series n. Series 2 minus series n equals series n. Alright? Okay, well, I know what this is from before. So that means series 2 equals, oops, negative 4 there. So if I add both sides, it'd be negative 3 series n. And from before, what did we show? We showed that series 2 was 1/4. So this is 1/4 equals negative 3 series n. So that means series n must equal negative 1/12. Okay? And that's what we were here to show. Alright. So there's your proof. Okay? Now, what does that mean? Does that mean it really does equal that? Well, it means I showed it. Okay? If you take calculus, then you will see that in another way this is not true. Okay? Of course, that series would just diverge. But in a sort of sense, this does converge to negative 1/12. What's interesting to me is that you can prove this using more advanced techniques, and you'll still get that same number. So that's what's at least interesting to me. Now, well, maybe you're just wrong in 2 different ways. Okay, well, that's kind of interesting. But what else does this mean? It might mean that in another dimension, that that's what it equals. Or if you're on the side of this is all just nonsense, then you can also at least respect the infinity. I almost said the number infinity, but you can respect the idea of infinity, that in some sense it's very similar to zero. Okay, there's a lot of properties that infinity and zero have in common, and they can, you know, have these strange results. Like if you divide by zero or you divide by infinity, some strange things will happen. So maybe you can at least appreciate it in that way. Okay, but it's one of my favorite proofs, so hopefully you like it.